A very good morning, students. Yesterday, I have already mailed you deleted and non-evaluated syllabus details and also the textbook which is highlighted. The highlighted part is not asked for board exam, remember. The entire Maharashtra is using this copy. So it's very proud thing for me. Whatever the syllabus reduced by me, the entire Maharashtra now using this book. So I request all the students go through this copy. If you have any problem regarding the deleted or non-evaluative syllabus, this deleted and non-evaluative syllabus, it is only for HSC board exam. CET and JEE and NEET will make a separate notification for the reduced syllabus. If the notification is not made, so there will be no any reduction of syllabus for the competitive exams. See, the decisions will be taken by the governments and it will be informed from the newspaper also and from the news also. So don't make confusion. This reduced syllabus only for HSC board exam for the academic year 2021. Next year, the entire syllabus will be there due to the COVID-19 situation. This decision is taken by the government. So yesterday, in aldehydes and ketone chapter, we discussed the two very important reactions. Just I want to take a quick review of these reactions because these are very, very important reactions, Aldol condensation reaction and Cannizzaro reaction. Once we will take a quick review of this Aldol condensation. Many times it is asked for board exam for 3 marks. But the main thing, this year, they reduce the mechanism part of this reaction. Only the reaction will be asked for 2 marks. Now 2 marks are sufficient. It will be not asked for 3 marks because if the mechanism is asked, then it will be the big question of 3 marks. So if this year, if the question was set on this aldol condensation, it will be for 2 marks. So the name aldol means it is a combination of aldehydes and alcohols. The main condition, there are 3 main conditions for this reaction. First one is aldehydes and ketones, they should contain alpha hydrogen. And the second condition, in presence of dilute base, NaOH, KOH or Ne2CO3. And the third condition was 2 molecules of aldehydes or 2 molecules of ketones are used. So this is a aldol condensation reaction. This is the first molecule. This is second molecule. This is containing alpha hydrogen. So what is the role of the base? The base will pick up 1 hydrogen. The carboanion is formed. This carboanion, it will attack the carbonyl carbon of the first molecule and we will get the aldol product. An aldol product after heating, they gives alpha beta unsaturated aldehyde. This is a alpha beta unsaturated aldehyde. Now you are familiar with what is meant by alpha carbon, what is meant by beta carbon. Unsaturated means double bond is there. So this reaction, it is asked for 2 marks. We will take example of ketone also. You can take the examples of aldehydes and ketones. It is called. So this is a mechanism part. It is deleted from the syllabus. But if you have any problem, you can go to this, go through this mechanism. With the mechanism, it is very easy to understand how the reaction takes place. Step 1, what is happening in step 2 and step 3. So I request all the students, please go through this reaction. Write 10 times at least. So my request is write this reaction for 10 times. So it will be very easy for you. Cross aldol condensation, it is a condensation between 2 different aldehydes or 2 different ketones. This is not asked for board exam, but yesterday I have explained in detail. Then Cannizzaro reaction, this is exactly opposite to the aldol condensation reaction, in which the aldehydes which do not contain alpha hydrogen, these are used. Again, 3 conditions are there. First one is alpha hydrogen should not be present, and then 2 molecules are used, and strong alkalis are used here. And in case of aldol condensation, weak alkalis are used. They also may ask for the board exam, write the any two differences between aldehydes and ketones. So be ready for such type of questions. This is also many times asked for board exam for 2 marks. So all these reactions are completed yesterday, and we are discussing about these Clemenson's and Wolff-Kishner reduction. These are two specific reagents which converts the carbonyl group Cl. The carbonyl group means this CO group is converted into methylene group CH2. These Clemenson's reagent is different and Wolff-Kishner reduction is different. These are the name of the scientist. Clemenson Clemenson reagent is a zinc amalgam in presence of concentrated HCl. Amalgam is when any metal it is combined with mercury, it is called as amalgam. So this is a zinc amalgam in presence of concentrated HCl. They gives CH2 group, that is methylene group. One example is shown here, aldehyde and one ketone. Then we are discussing about the Wolff-Kishner reduction. In case of Wolff-Kishner reduction, the same carbonyl group is converted into CH2 group, but the reagents are different here. The reagents are hydrazine. We know about this hydrazine is NH2 group, NH2 and followed by the hydrolysis NaOH or KOH in presence of ethylene glycol. I will take one example of this Wolff-Kishner reduction. See, this is a general reaction first. This is a carbonyl, any carbonyl group. This may be aldehyde or this may be ketone. This NH2 group is hydrazine minus H2O. You know this ammonia derivatives reaction. We already learned this oxygen and these two molecules of hydrogen. These are removed. We get first hydrazone here. So hydrazone is prepared from the hydrazine. There are two H2 molecules, and then this oxygen it will be removed. This is imine base, imine intermediate. Hydrazone is imine intermediate. This imine intermediate it is broken by using this is a ethylene glycol. It is used as a solvent, but the reagent is KOH or NaOH you can use, and we get here methylene group plus N2 gas is evolved. So this is a general reaction I have shown. I will take one example, aliphatic aldehyde, and this is aromatic ketone is used here. So propanol, when it is treated with hydrazine, first hydrazone is prepared. How the hydrazone is prepared? There is two hydrogens and this oxygen imine intermediate, it will be formed, and this imine intermediate will be treated with hydrolyzed with base by using KOH in presence of ethylene glycol. It is used as a solvent only. So we get here CH3, CH2 and CH3. We get here alkanes. So aldehydes directly these are converted into alkanes. CO group is converted into CH2. This is another example of ketone is given. See, this CO is converted into CH here. See the product directly. So what is the advantage of these reactions? Wolff-Kishner reduction is used to prepare the straight chain alkyl substituted benzenes, which are not possible by Friedel-Crafts alkylation reaction. You know the Friedel-Crafts alkylation reaction in which CH3Cl group is used and CH3 plus is electrophile. Now, the next reaction is electrophilic substitution reactions. Many times in many chapters before this, in halogen derivatives also, in alcohols also, in phenols also, in ethers also, you learned about this electrophilic substitution reaction in which electrophile is substituted. And mainly the electrophilic substitution reactions are halogenation in which halogen is added, then nitration in which NO2 group is introduced. In nitration, we are using the mixture of concentrated HNO3 and mixture of concentrated H2SO4, in which NO2 group is substituted. In case of sulfonation, SO3H group is substituted there, and the reagent is concentrated H2SO4. Then Friedel-Crafts alkylation, Friedel-Crafts acylation. These are the electrophilic substitution reactions. like chlorobenzene, like benzene, like anisole, like phenol. These aldehydes, ketones also undergo the electrophilic substitution reaction. But main thing is the group attached to benzene. See, I already explained the electrophilic substitution reactions depends upon the group attached to this benzene, in which the CHO group is electron withdrawing group, remember. This CHO group is electron withdrawing. That's why we get only one product here at the meta position. But if you see the reactions of chlorobenzene, if you see the reactions of anisole, if you see the reaction of phenol, in which we are getting the two products, ortho and para products, because in that reactions, the group attached to this benzene or aromatic uh, family, it is electron donating groups. Chlorobenzene, in which the chlorine is electron donating. In case of phenol, the OH is also electron donating. In case of anisole, OCH3 group was electron donating. So in that case, in that electrophilic substitution reactions, we are getting two products, ortho and para. But in case of aldehydes, this CHO group, as it is electron withdrawing, we get here only one product. It is a meta directing, because you know, in 11th standard also we studied this. When the deactivating groups are attached, this is deactivating group. When deactivating groups are attached to the benzene, we get only one product at the meta position. So one reaction is explained here. This is a nitration of benzaldehyde, say the mixture of concentrated HNO3 and mixture of concentrated H2SO4 at 273 and 283, means the temperature is very less, very low, and we get here meta nitrobenzene. Meta nitrobenzaldehyde. If you carried out the chlorination, we get here chloro at this meta position. If you carried out the bromination, we'll get the bromine here. If you carried out the Friedel-Crafts alkylation, we get here CH3 group. If you carried out Friedel-Crafts acylation, we will get here CO CH3 groups. So this halogenation, nitration, Friedel-Crafts alkylation, acylation, the role of the reactions are same. All these are electrophilic substitution reactions in which the electrophile is substituted. But in case of this aromatic, in case of these aldehydes, only one change is CHO group is meta-direct. So I think you are well familiar with the electrophilic substitution reaction. I'm not going in detail. So the uses of aldehydes and ketones, this may be asked for 2 marks. Aldehydes and ketones, these are used as a solvent in many chemical industries. Then these are also used as a starting material and reagents for the preparation of alcohols. You see, aldehydes are prepared by using, alcohols can be prepared by using aldehydes. Then in other products also they are used as a starting material. This formaldehyde is very important, because I think 2017 question paper, this MCQ was used, formalin. What is a formalin percentage? It is a 40% solution. Formaldehyde is well known as a formalin, 40% solution. This percentage was asked, I think, in 2017 question paper. So formalin is 40% solution in water, used to preserve biological specimens, and it is also used to prepare the bakelite. Bakelite is one of the polymer which we will discuss in the chapter number 15, Introduction to the Polymer Chemistry. What is meant by this bakelite? All the electrical switches, it is made up with bakelite, remember. We will discuss in detail in the chapter number 15. It is Introduction to the Polymer Chemistry. The next use is acetaldehyde. It is used for the preparation of acetic acid and DDT. Benzaldehyde, it is used in perfumes and in dyes industry. Then acetone, which is a very important ketone, we are using in laboratory. It is very pleasant smell. And acetone having many important uses. It is also used as a nail paint remover. Acetone is used as a commercial solvent in many reactions. This acetone is used because it is having very less boiling point, 56 degrees. It can be easily removed. by just heating it, and we can recollect the product. So as a solvent purpose, it is used acetone. Also, it is used in manufacturing of many explosives and paint removers. Already I explained in nail paint remover and paint remover, it is used. It is also used for the preparation of in many plastics, drugs, perfumes, and adhesives. So this may be asked for 2 marks. Write any 2 uses of aldehydes and ketones. So just go through the uses. The next part, I am coming to the carboxylic acid part. Carboxylic acids, acidic character. All the students remember this question is asked for CET. They will give the different acids, they will give the alcohol, they will give the alkanes, and question will be asked which of the following is more acidic, and we have to arrange the according to the strength of acidic character, according to the decreasing strength and increasing strength. So if you didn't understand the theoretical part behind it, it is very difficult to arrange which is most acidic and which is the least acidic. So acidic character, remember, in case of carboxylic acid, C is due to the carboxylate ion. See how this carboxylate ion is formed. I will explain. When this carboxylic acid is dissolved in water, this is a carboxylate ion. This hydrogen, this carboxylate ion, it is also called as the conjugate base. So the stabilization of conjugate, depending upon the stabilization of conjugate base, the strength of the acid is depend. So this conjugate base is stabilized with the resonance here. This O minus, this electron density can be shifted, and it will be stabilized. There are two structure here, 1, 2, 3. This is a resonance hybrid. So stabilization of this carboxylate ion is responsible for the acidic character. So for the stabilization purpose, there are two values. Higher the Ka value and lower the pK value, stronger is the acid. We have to remember any one of this Ka value. The Ka value is larger and pK value is lower, acid is very strong. So we will discuss with one example here. See, what is the influence of electronic effects? Electronic effects means these are the electron plus I effect, then minus I effect, and plus R effect, and minus R. Electron donating inductive effect, electron withdrawing inductive effect, electron donating resonance effect, and electron withdrawing resonance. There are 4 electronic effects. So these 4 electronic effects are responsible for the acidity of carboxylic acid. Remember, I will explain in detail because in CET, 100% this question is there. Which of the following is most acidic and which of the following is least acidic? It is very simple. See, I will give some hints how to remember. See here. These are the some acids are given, and we can clearly see this is a fluorine is attached here, and this is a chlorine is attached here. All these acids are haloacetic acids. This is a fluoroacetic acid, this is chloroacetic acid, this is bromoacetic acid, this is iodoacetic acid, and this is only the acidic acid, acetic acid. See what is happening here, pKa values are increasing here, and you know, as per this statement, when the pKa values lower the pK values, stronger is the acid. But see in this example here, the pK values are increasing, means the strength of acid is decreasing. Means this CH3COH is a very weak acid, and the strong acid is a fluoroacetic acid. Why such type of difference is there, I will explain. Because this fluorine is electronegative. This is the most electronegative. As we down the group in group number 17, fluorine, chlorine, and bromine iodine, this electronegativity decreases, and if this electronegativity decreases, see the strength of the acid is also decreases. Means if this fluorine is electronegative, it will stabilize the resonance. See here. In this highlighted part, I will explain. This X is halogen. What is the role of this X? X will pull the electron density from this CH2, and it will be get stabilized. This conjugate base, it will be get stabilized due to the this X. So as the electronegativity increases, the acidity will be increases. And what is the role of this CH3? I will explain. This CH3 is electron donating. This is the plus R. If the more number of CH3 groups are attached, the acidity will be decreased, because this CH3 number of R groups, they will donate the electron density towards this CH2. Means this arrow will be reversed. This what is the role of these halogens? Halogens will pull the electron density, but the alkyl groups will give the electron density to this CH2, and this will be destabilized. So if the destabilization increases, the acidity will be decreases. So we have to remember one important thing: the stability of the carboxylate group is very important, and the stability will be increased when electron withdrawing substituents are attached, in which NO2 is there. See this the three examples I will explain again. This is asked for board exam. That's why I have given monochloroacetic acid, in which one chlorine is there. Then dichloroacetic acid, two chlorines are attached here. And trichloroacetic acid, three chlorines are attached here. So if you see the pK values, this is a trichloroacetic acid having the pK value is 0.6. So this is the most acidic, because as the number of halogens increases, what is the role of these halogens? This will pull electron density, and the resonance will be more stabilized, in which in case of monochloroacetic acid it is less stabilized. In case of dichloroacetic acids it will be again more stabilized. In case of trichloroacetic acid, the resonance stabilization is most. That's why see the acidic values here. So these questions are very important for the CET purpose. Then if we compare in this problem, the same problem is also given in your textbook. See, I want to clarify one thing. Whatever the boxes which are given in the textbook, no any question will be asked for the board exam. But I want to clarify one thing, because as I am a member of that committee, what is the finalized decision in that meeting, I will explain. Same problem it will be not asked for exam, but they will change the groups also. See here, in this alcohols, phenols and carboxylic acids are used, but at the time of board exam we can give here alkanes, we can give here phenols, we can give here carboxylic acids. We can change these groups. So don't neglect the problems which are given in the textbook. Same problem it will be not asked, but they can change the values also, and they can change the matter also. So don't neglect the problems. I am talking about only problems. Whatever the content, do you know, can you recall, then can you remember, try this, internet my friend. So this is completely evaluated. No any question will be asked on these boxes, but pay attention to these boxes which are in which the problem is given. So don't neglect the problems. Problems will be changed. So I want to discuss this one important problem with you: alcohols, phenols, and carboxylic acids. See, for the acidity, we have to check the conjugate base here. So this is the conjugate base of alcohol. This is alkoxide. This is the conjugate base of phenol. This is phenoxide. This is the conjugate base of carboxylic acid. This is carboxylate. So what is happening in case of alcohols? There is R group, and already we discussed what is the duty of this R group. This R group is electron donating, and if this R is electron donating, this conjugate base will be destabilized. This is destabilized, so it is less acidic. It is less acidic, means it is neutral actually. And in case of phenol, see this phenoxide ion. This phenoxide ion is stabilized due to the aromatic system here. This aromatic system is minus R effect. It electron density will be shifted, and it will be this resonance stabilized. Due to this resonance stabilization, this conjugate base is stabilized. Then I am coming to the RCOOH. This is a carboxylic acid, and this is a conjugate base. Hydrogen is removed. Now see, this conjugate base is well stabilized due to the resonance. This conjugate base is very stabilized due to the resonance. Resonance stabilization is good because the resonance structures are equivalent to each other. So if you understand the stability of conjugate base, you can solve the question of acidity and basicity. You can go through this example. Then this is a homework I have given. We have to show the arrows. It is very depend upon the previous one. Then I am coming to the acidity of aromatic carboxylic acids. Directly I am coming to this example. CA, this COH, it is having the pK value is 4.2. This is NO2, pK value is 3.41, and this is a 4-methyl benzoic acid. So such type of questions are asked for board exam. Which of the following is most acidic? Which of the identify the most acidic compound? 1, 2, 3. So I want to clarify one thing here. NO2 group, see here, NO2 group is electron withdrawing, so it will be most acidic. So NO2 group, what is the role of this NO2 group? It will pulls the electron density, and it will be the conjugate base will be very stabilized. See, this CH3 is R group. It will give the electron density, so it will be destabilized. And this COH, no any group is attached, so it is least acidic. So the see the values, it's 4.2, 4.4 pK values. If the pK values are more, it will be less acidic. So सबसे less acidic will be this 4.4 pK value, this COH, and this CH3. 4-methyl benzoic acid is least acidic. Then this one, and the more acidic is 4-nitrobenzoic acid. So electron withdrawing groups like Cl, Cn, NO2, as the more number of NO2 groups, more number of halogens, more number of cyanides are attached, the acidity will be more, and acidity will be decreases when such type of CH3 group, then OH group, then OCH3 group, NH2, these are all electron donating groups. So they will decrease the acidity of the benzoic acids. Then this part is eliminated, remember. This is a clear cut mentioned in the syllabus copy also. What is the given? Laboratory test for carboxylic. This entire part is deleted for this year, but the next year this will be for exam. This is also deleted. So I am coming to direct the reactions of carboxylic acid. This is the last part of this chapter. Formation of acid anhydride. It is very simple reaction. Mono carboxylic acids. These are monocarboxylic acids. You know the word monocarboxylic acid means they contains only one COH group. So these are the two molecules of ethanoic acid. Ethanoic acid is also called as acetic acid. These are the sometimes they have given the IUPAC names. In some reactions they have given the common names. You can use any name. आपको जो नेम अच्छा लगेगा वो नेम आप यूज कर सकते हैं. ऐसा कुछ नहीं है कि IUPAC नेम यूज करो, कॉमन नेम यूज करो. You can choose any one of the name, either common name or either IUPAC, but one name should be confirmed. So these ethanoic acid, they when these are treated with dehydrating agent. Now you are familiar with the dehydrating agent. There are 3 dehydrating agents we are using in our 12th standard. The first one is H2SO4, then second one is alumina, and third one is P2O5. Third one is P2O5, that is the phosphorus pentoxide. These are used as a dehydrating agent. So what is happening when these acids are treated with a dehydrating agent? H2 molecule is removed. See, if the H2 molecule is removed, we get here anhydride. Anhydride, the name indicates it is a anhydride means water molecule is not there. That's why it is called as anhydride. But when water molecule is added in this hydride, again they gives back the acids. So the reversible reaction can take place. So acid anhydride is prepared by using acids by treating with dehydrating agent. What is the role of dehydrating agent? To remove the water molecule. See, the water molecule is removed. This H, this hydrogen, and this OH is removed, and these two molecules are joined together. We can see clearly here. So if you write the reaction, then we will understand. One hydrogen and this OH is removed, and these two molecules are bonded together here, this with oxygen. So this ethanoic anhydride or acetic anhydride, it is prepared. So better yield we can prepare. Better yield of these anhydrides can be given by when these are treated with sodium carboxylate and acyl chloride. This is another reaction by which we can prepare the anhydride also. This is a sodium carboxylate, the sodium salt of carboxylic acids. When carboxylic acids are treated with NaOH, we get this sodium carboxylate. And this sodium carboxylate, when it is reacted with acyl chloride, now you are familiar with these acid chlorides. In many reactions, these acid chlorides are used. In Rosenmund reaction, it is also used. Sodium carboxylate. So this sodium carboxylate, when treated with acid chloride, we get the acid anhydride. This acid anhydride and these following acid anhydride, these are same, but we are getting the better yield here. Better yield means the percentage of the product is better in this. So this, how the acid chlorides are prepared and how this sodium carboxylate is prepared, it is shown here. Already you know these reactions are completed in chapter number 10. This is thionyl chloride and this is acid. So you know these reactions. I'm not explaining in details. So reduction of carboxylic acid, it is important. It is as for 1 mark for the board exam. Remember, the reduction of carboxylic acids, it is as per board exam. Make a note there. Reduction can be done by using the reducing agent. Now you are familiar with the reducing agents. I will tell you the at least 4 reducing agents. First one is catalytic hydrogenation, H2 in presence of PT, platinum or palladium. It is, if it is not available, then go to the lithium aluminum hydride, that is called as LAH. Then third one is NaBH4, that is sodium borohydride. If all these are not available, we can use here B2H6. All these are reducing agent. Then instead of these reducing agents, now you are familiar with the new reducing agents. Wolff-Keshner reduction is also there. Then Clemmensen reduction is also there. So all these are reducing agents, but for the carboxylic acids, they are directly reduced to the primary alcohols by powerful reducing agents like lithium aluminum hydride. Short form is LAH. And better yields are obtained by using diborane. Diborane, it is used, this word diborane reagent is used in the chapter alcohols by the preparation of alcohols by using hydroboration reaction. So my request to all students, please go through this diborane reaction again, because this reaction is carried out according to the Antin-Markovnikov's rule. This reaction is also important. So diborane here, see, the diborane is very specific here. Diborane does not easily reduce the COOR, that is ester group, then NO2 and halogens. So that's why it is shown in bold. These are the exceptions. See here, diborane does not easily reduce the esters, NO2 and halogens, and also the sodium borohydride, NaBH4, does not reduce the COOH group. So these are selective, these are used as a selective reduction. When the specific group you have to reduce, we have to use these two reducing agents, remember. And lithium aluminum hydride is we can use at any time. Lithium aluminum hydride, you know the use of lithium aluminum hydride. It converts the carbonyl CO group into direct methylene group, that is CH2 group. So it is a simple reaction, RCOH, lithium aluminum hydride in first step, and in the second step acidic hydrolysis takes place. We get RCH2OH. Only this CO carbonyl is converted into CH2. We can do the reduction by using Wolff-Keshner. We will get the same product. If you carried out the reduction by using Clemmensen's, also we can obtain the same product. That is, primary alcohols are obtained. Then reaction with ammonia molecules here. I want to finish this chapter, so I will take very fast, because the whatever the time given for this reaction is already completed. Already this is the 6th lecture going for the halogen, aldehydes, ketones, and carboxylic acids. Actually, it should be completed in 5 lectures. Carboxylic acids reacts with ammonia to give the ammonium carboxylic salt. See, I will take one example, so it will be very easy. I will take one aliphatic carboxylic acid, and I will take one aromatic carboxylic acid. CH3COH. This is aliphatic carboxylic acid plus ammonia. We will get here the intermediate, that is ammonium carboxylic. This is the salt, and this salt is when treated heated with only heated, it gives CH3CONH2. We get here amides. Means in the first step we are getting the carboxylate salt, and in the second step when it is, we get the amides here. So this is the main thing, how the amides are prepared. See this phthalic acid, which is required in chapter number 13, amines. In amine chapter, we required this. So I am explaining this one. This is phthalic acid. Phthalic acid is dicarboxylic acid. 2 COH groups are there at 1 and 2 position plus ammonia. We get here ammonium phthalate. This is a intermediate, and this intermediate, when it is there, 2 water molecules are removed. We get here phthalimide. This phthalimide, which is when strongly heated, we get phthalimide. See here, this is a phthalimide, and this is a phthalimide in which the water molecule, the ammonia is removed from this. This phthalimide is required for the one important reaction, and that important reaction, the name of that reaction is Gabriel phthalimide synthesis, which is in chapter number 13. So in chapter number 13, directly we will start from this one, phthalimide. But how this phthalimide is prepared, you must know these things. You must know this, how this phthalimide is prepared. So I am coming to the next reaction with PCl5, PCl3 and SOCl2. So I want to clarify all these reactions of phosphorus pentachloride, then phosphorus trichloride, then thionyl chloride. These are detailed explained in chapter number 10. Halogen derivatives also in detail explained in chapter number 12, that is alcohols. The mechanism is same. These all are nucleophilic substitution reactions in which the chlorine is substituted, OH is removed and chlorine is substituted in all these reactions. So last reaction is, I think this is the decarboxylation of carboxylic acid. The word decarboxylation means we have to remove the CO2 molecule. In 11th standard also we learned about the decarboxylation. Decarboxylation means we have to remove minus CO2. And for the removal of minus CO2, this is a specific reagent, soda lime. Soda lime is a mixture of NaOH and CO. The proportion is 3:1. See in this example, this is a sodium acetate, it is sodium salt plus mixture of NaOH and CO. This is soda lime. So soda lime is used directly. This CO2 is removed, and we get here alkanes. So the one example is shown here, sodium acetate. And if this NaOH and CO is used, direct this CO2 it is removed, and we get here direct alkanes, and this is a byproduct. Na2CO3 is byproduct. So I request all the students, we have to prepare one chart, and in that chart we have to write this what is which reagent is used for oxidation, which reagent is used for decarboxylation. This reaction is eliminated. This is not included in your syllabus. Hale-Ohlert reaction. This is deleted part. This is also the deleted part. And last one is uses of carboxylic acids. And I will explain, and we will stop here. Formic acid is used in rubber, dyeing, leather industries. Acetic acid is a chief constituent of vinegar. Then acetic acid is used as a solvent. Then adipic acid. Adipic acid is CH2,4-COH. It is used for the preparation of nylon 6.